Let's take a look at zeros of polynomial functions. And first, let's just refresh our memory a little bit. Now recall, we had problems that may look like this. X squared minus 5x plus 6 is equal to 0. And we would factor this. This would be x minus 2 times x minus 3 equal to 0. Then we set each factor equal to 0. So I set x minus 2 equal to 0 and x minus 3 equal to 0. And we get x equal to 2 and x is equal to 3. Now these would be our zeros. They're also called our roots. Now let's take a look at how to find zeros on a TA3, TA4 calculator. Our first step is to put our polynomial on y1 and 0 on y2. Second step, we're going to do second trace. We're going to choose intersect. Then we're going to do inner on first curve. And we'll do enter on second curve. Now for the guess, we're going to input an x value close to your answer. And press enter. So input an x value close to your answer and press enter. We'll talk more about later, well, how do you tell what's your answer? And then step 3, if you have decimals, excuse me. If you have decimals, you'll do second mode exit out. And then you'll do math, enter, enter. So math, enter, enter. Well, let's take a look at our first problem. F of x is equal to x to the third minus 3x squared minus 18x plus 40. And the instructions are find all the zeros. Well, remember over here where we found the zeros? First thing we did is we set it equal to 0. So that's what we have to do here. So we'll set that equal to 0. And we want to solve this. Well, we're going to go through our steps on our calculator. So I'm pressing my y equals. It says put polynomial on y1. So I'm going to declare out wherever's on that line. And then we'll put an x to the third minus 3x squared. So x caret 3 minus 3x squared minus 18x plus 40. Now you have to have 0 on y2. So I'm going to down arrow to y2, so my flashing cursor is there, and I'm going to put 0 there. This process does not work unless you put 0 on y2. Now to make sure you're not zoomed out or anything like that, press zoom and choose 6 for Z standard. That'll set everybody back to the standard viewing window. Okay, so now we're ready to do step 2. Second trace. So I'll press second and then trace. Now I say choose intersect. You see intersect is our fifth one. I can down arrow to it and press enter on it, or I can press the number 5 and it'll choose it. Now we do enter on first curve. Now we're not talking about anything special there. You notice in the lower left hand corner it says first curve. So all you do is press enter. Then we do enter on second curve. You know in the lower left hand corner it says second curve. So you just press enter. Now if you haven't been able to go past first curve or second curve, it probably means that you don't have 0 on y2. So go back to y equals, put 0 on y2, and then continue the process. Now you notice it says guess. It says input an x value close to your answer and press enter. Well, our first answer looks like -4 maybe. So let me put in -5. So the negative is the one in the very bottom row. So do -5, and I'll press enter. And it tells us our first answer is x equals -4. One of the things the fundamental theorem of algebra tells us is that our largest power tells us how many answers we're going to have. So the x to the third tells us we're going to have 3 answers. And as we can see by this first answer we found, our answers are where it crosses the x-axis. So you see it's got the flashing cursor on -4. Well, it looks like our next one is 2. So let's go through the process again. I'm going to do second trace, choose intersect, press 5. Enter on first curve, enter on second curve. Instead of actually inputting an x value close to our answer, I can just type in our answer. Like I think this is 2, so let's put in 2 and then press enter. And it comes back and tells us the intersection is x equals 2. So that's our second answer. Well, we got one more. This one over here looks like 5 or 6 or something like that. So I do second trace, choose intersect, enter on first curve, enter on second curve, and I'm going to right arrow over to put my flashing cursor closer to what I'm trying to find. This is a graphical way of entering the guess. Instead of actually inputting numbers, you just use your arrow keys to move the flashing cursor over closer to the one you want to find. Now it doesn't have to be right on top of it. And I'll go ahead and press enter. And it comes back and tells us this intersection is x equals 5. Now our largest power is x to the third. We just found 3 answers, so we're done with that problem. Let's look at our second example. Okay, we got f of x equals 4x to the third minus 17x squared plus 16x minus 3. We're going to find the zeros, so I'm going to set that equal to 0. So 4x to the third minus 17x squared plus 16x minus 3 equal to 0. Again, the largest power is x to the third, so we're going to have 3 answers. Let's go put this on y1. So press y equals, press clear. I get x caret 3. Now, oops, lied to you. 4x to the third. So we do a clear. 4x caret 3. Now, if you got one of those fancy newer TI-84s that throws it in exponent mode, to get out of exponent mode, like if you got x and this actually looks like this third power there, you press your right arrow key before you do the rest. Then minus 17x squared plus 16x minus 3. Now you should still have 0 on y2, so you shouldn't have to change that. So let's do a second trace, choose intersect. Looks like maybe 3, 1, and maybe a half, maybe 1/3. Now you see it says first curve, so we press enter on first curve. It says second curve, so we press enter on it. And for the guess, let me type in 0 and press enter. Now it comes back and tells us 0.25. Well, this is step 3. If you have decimals, second mode, and then math enter enter. So we're going to do second mode, math enter enter. And we get 1/4. So that's our first answer. Well, we got two more answers, so let's do a second trace again. Go through the process. Choose intersect. Enter on first curve, enter on second curve. I think it may be 1. Let me put 1 in for the guess. Yep, comes back, tells us the intersection is x equals 1. And let's find the next one. It's like 3 or 4. So we do second trace, choose intersect, enter, and let me put in 3. And it comes back and tells us 3. Now our largest power was x to the third, which means we had 3 answers, and we found 3, so we're done with that problem. Let's look at the next one. We got find all the zeros, so we got x to the third minus 4x squared plus 9x minus 10 equals 0. So we want to put our polynomial on y1. So I'm going to go to y equals clear, and we got x to the third, so I do x caret 3 minus 4x squared plus 9x minus 10. Now we already have 0 on y2, so we're good there. So let's go through our process. I'll do second trace. Now I'll choose intersect. Now it comes up and says first curve, I'll do enter on that. Comes up and says second curve, I'll do enter on that. And for the guess, it looks like 2, so let me put in 2 for the guess and press enter. And sure enough, it's 2. Now that's the only place it crosses the x-axis. So that's the only answer we can get from the calculator. But we have x to the third, which means we have 3 answers. Well, what we're going to do is we're going to take this answer we just found, and we're going to plug it into synthetic division. Now remember, synthetic division, this is x to the third, this is x squared, this is x, and this is no x. So I'm going to add 1 plus nothing's 1. Multiply, you always multiply by the number up in the box, but number you just put down there. 2 times 1 is 2. Add, negative 4 and 2 is negative 2. Multiply, 2 times negative 2 is negative 4. Add, 9 minus 4 is 5. Multiply, 2 times 5 is 10. And add, negative 10 plus 10 is 0. Now we have to get a 0 there. If the calculator told us it's one of our answers, you have to get a 0 there. There's no choice. Now this was x to the third. This is 1 degree lower. So this is x squared, this is x, and this is our no x, our constant term. So we're going to have x squared minus 2x plus 5 equal to 0. So after we plugged in our one answer we found via the calculator, we got it down to a problem we can actually solve. Now this doesn't factor, so I can use quadratic formula. Now a is what's before your x squared, which is 1. B is what's before your x, which is negative 2. And c is your number at the end, which is the 5. Our quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a, which gives us negative 2 plus or minus negative 2 squared minus 4 times a, which is 1, times c, which is 5, all over 2a, so 2 times 1. Well, negative gives us a positive 2, plus or minus. Negative 2 squared is 4, minus 4 times 1 times 5 is 20, over 2. Now 4 minus 20 is negative 16, over 2. With a square root, we're looking for a pair of numbers. Well, 4 times 4 gives you 16, and a negative inside of your square root gives you an I. So this comes out as 4i over 2. Now, if you have an imaginary part, you can split them up into separate fractions. The real part over your denominator, and the imaginary part separate. 2 over 2 is 1, plus or minus 4 divided by 2 is 2 with an I. Fundamental theorem of algebra says you're going to have three answers. It doesn't say they're all going to be real. Here we have two imaginary. This plus or minus is where our other two answers. Let me start a new page. Yeah, let's look at the next problem. It says find all the zeros, and we got x to the fourth plus 5x to the third minus 5x squared minus 15x plus 14 equal to 0. Now I say find all the zeros, but I've actually already set this up equal to 0. So we're just solving this. Now our largest power is x to the fourth, which means we're going to have four answers. So let's see what we can find via the calculator. So press y equals, press clear. We got x to the fourth, so we do x caret 4 plus 5x caret 3 minus 5x squared, wherever x squared is, there it is, minus 15x plus 14. Now I have 0 on y2, so that's good. We'll do second trace. Choose intersects. We'll do 5. And that looks like it crosses at negative 5, negative 6, something like that. Let me do inner on first curve, inner on second curve, and let me put in negative 5 for the guess. Gives us negative 5.316625. Well, that's okay. We've already looked at how to handle decimals. You exit out, so I do second mode, and I press math, enter. Well, it doesn't change to a fraction, so we can't use that answer. So let's go on and see what we can find. We don't want any decimals at all. So I do second trace, choose intersect. Looks like negative 2. So we do inner, and negative 2. And sure enough, it says negative 2. Next one looks like 1 maybe. So let's do second trace, choose intersect, number 5. Inner on first curve, inner on second curve, and I'll put in 1 for the guess. And sure enough, x equals 1. Now notice, it comes down a little bit below the x-axis and goes back up. That means there's two answers right there. So let me put 2 in for the guess. I'll do second trace, choose intersect, inner on first curve, inner on second curve, and I'll put 2 in for the guess. Now notice this comes up with some nasty decimal. This won't change to fraction. I know that because this one over here wouldn't change to a fraction. The way these always work is if you got one that won't change to a fraction, you'll have 2 that won't change to a fraction. Now, I chose 2. If you go too far out, and as weird as this seems, 3 is too far out for your guess. If I do second trace and choose intersect, inner, and I'll put 3 in for my guess. Notice how it comes over here and finds negative 2. So it kind of wraps around. So it'll do weird things if you get too far away from your zeros. So choose a value fairly close. Well, that's no good. We needed 4 answers. We found 2. Well, let's work with that. I'm going to take my first answer. It doesn't matter which one you actually start with, but I'll start with negative 2. And we're going to plug that into synthetic division. Now this is x to the fourth. So we'll add 1 plus nothing's 1. Multiply, negative 2 times 1 is negative 2. Add, 5 minus 2 is 3. Multiply, negative 2 times 3 is negative 6. Add, negative 5, negative 6 is negative 11. Multiply, negative 2 times negative 11 is 22. Add, negative 15 plus 22 is 7. Multiply, negative 2 times 7 is negative 14. And 14 minus 14 gives me 0. Again, no surprise. If calculator told us this was one of our answers, we have to get 0 as a remainder. Now this is now down to x to the third. Well, we're going to take our second answer and we're going to plug it in the line we just found. So we just continue on. So then I add multiply, add, multiply, add, multiply, add, and we get another 0. Again, no surprise, calculator told us this was going to be one of our answers. And now we're down to x squared. Each answer you find takes it down one more power. So we're left with x squared plus 4x minus 7 equal to 0. Now this won't factor, so we have to use quadratic formula again. A is the number before x squared, which is 1. B is the number before x, which is 4. And C is our number at the end, which is negative 7. Excuse me. Our quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So we got negative 4 plus or minus square root of 4 squared, that's b squared, minus 4 times a is 1, times c, which is negative 7, all over 2a, which is 2 times 1. Now 4 squared is 16. Negative 4 times 1 is negative 4 times a negative 7 gives us a positive 28. 2 times 1 is 2. 16 plus 28 is 44 over 2. Now 44, the prime factorization of it is 2 times 2 times 11. And remember, with a square root, we're looking for a pair of numbers. Here's a pair of 2s, so the pair of 2s is going to come out in front as a single 2. So we've got negative 4 plus or minus 2 square root of 11 over 2. Now remember the quadratic formula. If you can divide this number, and this number by the same number, do so. And they're all divisible by 2. So that gives us negative 2 plus or minus 1 square root of 11 over 1, which is negative 2 plus or minus square root of 11. The reason why these would not change to fractions when we try to do the second mode math inner is they're not really fractions, they're radical answers. Well, let's look at our next problem. We've got x to the fourth minus x to the third plus 3x squared minus 9x minus 54 equal to 0. Same instructions, find all the zeros. We have x to the fourth as our largest power, so we're going to have four answers. Well, let's go put this in our calculator. So press y equals, press clear, x caret 4 minus x caret 3 plus 3x squared, so plus 3x squared minus 9x minus 54, and then 0 on y2. So we do second trace, 2's intersect. Our answer again is where it crosses the x-axis, and this one's pretty obvious. It looks like negative 2 and 3. So let me just kind of write these down here. Negative 2 and 3. I'm not going to go through the steps to actually verify those. You could, enter on first curve, enter on second curve, put negative 2 in for the guess. And I'm going to show you why here. Since it's so obvious, I'm going to plug these in to synthetic division. So start with negative 2. Add. You always multiply by number up in the box whenever you put down there. Negative 2 times 1 is negative 2. Add. Negative 1, negative 2 is negative 3. Negative 2 times negative 3 is 6. Add. 3 plus 6 is 9. Multiply. Negative 2 times 9 is negative 18. Add. Negative 9, negative 18 is negative 27. Multiply. Negative 2 times negative 27 gives us positive 54. And add. Negative 54 plus 54 gives us 0. The reason why I didn't have to go through those is because it checks itself. If you get 0 as a remainder here, that means that's one of your answers. There's no doubt about that. That's actually called a factor theorem. Well, we started out with x to the fourth. this is now down to x to the third. Well, I'm going to plug in my other answer, the 3. Then I'll add 1 plus nothing. Multiply. You always multiply by the number up in the box, but number you just put down there. 3 times 1 is 3. Add. Negative 3 plus 3 is 0. Multiply. Number in the box by this number. 3 times 0 is 0. Add. 9 plus 0 is 9. And 3 times 9 is 27. And we get another 0. So that is indeed our second answer. Now this is now down to x squared, which is where we want to be. So we got x squared plus 9 equal to 0. Well, we don't have to use quadratic formula anymore. We can use the square root property. Square root property says you get the part that's squared by itself. So I'm going to take the 9 over to the right side. Becomes a negative 9. The square root property says you drop your squared and you put a plus or minus squared around the other side. Now square root, we're looking for a pair of somethings. 3 times 3 gives you 9. And a negative inside of a square root gives you an I. So our other two answers will be x equals plus or minus 3i. That plus our original 2 is our 4 answers. Let me start a new page. Time for that to blow up. So let me bring up a new tablet. There we go. And let's look at our next problem. It says find all the zeros. So we got x to the fourth minus 6x to the third plus 30x minus 25 equal to 0. Going to have 4 answers. So let's go plug this into our calculator. I'll press y equals, press clear. I got x to the fourth minus 6x to the third plus 30x minus 25, and we still have to have the 0 on y2. So I do second trace, and I choose intersect. It looks like negative 2 maybe. Let me do inner on first curve, inner on second curve, and put in negative 2. Doesn't look like it. That doesn't look like it'll change to a fraction. Negative 2.236068, so it's probably a radical. Let's get our next one. Looks like 1. So I'll do second trace, choose intersect, inner on first curve, inner on second curve, and I'll put 1 in. And yes, indeed, it is 1. Next one looks like maybe 2. So let me do a second trace. Choose intersect. Inner on first curve, inner on second curve. I'll put 2 in for the guess. That doesn't look good. That doesn't look like it changed a fraction. So let's find the next one. Looks like 5 or 6. So I do second trace. Choose intersect. Inner on first curve, inner on second curve, and we put 5 in for the guess. And it comes back and tells us x equals 5. Okay, now that looks like all we can get out of that. We needed 4 answers. We only got 2, but we know how to do that. We'll go ahead and just start plugging these in. So let's plug in 1 first. So I'm going to have 1, negative 6, 0, 30, and negative 25. Remember, if you're missing any powers, we're missing the x squared, you have to put a 0 there for it. And it's a good idea, even when you become comfortable with these, go ahead and put your largest power here, x to the fourth, and these are, you write them real small. X to the third, x squared, x, and our no x, our constant term. That ensures that in standard form, and you're not missing any powers. Okay, so let's add, multiply. You always multiply by number up in the box, but we put down there. 1 times 1 is 1. Add. That gives us negative 5. Multiply. Add. Multiply. Add. Multiply. Add. And we get a 0. No surprise at all. The calculator told us it was one of our answers. Well, we're now down to x to the third. And we want to plug in our second answer. So we'll continue on. Plug in the 5. So I'll add. Multiply. You take 5 times 1. Gives you 5. add. Negative 5 plus 5 is 0. 5 times 0 is 0. Add, multiply, add, and we get another 0. Again, there's no choice here. Calculator told you is one of your answers. You have to get a 0 there. Now this is x to the third. We're now down to x squared. And this is x, and this is our no x. So we got x squared minus 5 equal to 0. And this is another square root problem. So I'm going to take the negative 5 to the right side. Becomes a positive 5. And we're going to drop our squared, and we'll put a plus or minus square root around the other side. So x equals plus or minus 5 is our other two answers. Now again, they would not change to fraction because they weren't really fractions. They were radicals. Let's look at our next problem. We got x to the fourth plus 4x to the third plus 6x squared plus 4x plus 1 equal to 0. Well, let's go put this in our calculator. So press y equals, clear, x caret 4 plus 4x to the third plus 6x squared plus 4x plus 1. And we already have 0 on y2, so we're good there. So let's do a second trace, choose intersect. Looks like it comes down and touched at a point and went back up. I say touched at a point because I don't see it go below the x-axis anywhere. It looks like negative 1. Let's do inner on first curve, inner on second curve, and let's put 0 in for the guess. And we get negative 1.000852. When it comes down and touches at a point, it's going to do weird things. It won't give you your answer. It'll give you a number very close. But this looks like negative 1. So let's go through the process again, and let's put in negative 1 for our guess. So do second trace, choose intersect, inner on first curve, inner on second curve, and I'll put in negative 1. And it comes back and tells us negative 1. Again, it'll do that whenever you have it touching at a point. It does weird things. Well, that's no good. We needed 4 answers. We only got 1. Well, let's plug that into our synthetic division. So I got 1, 4, 6, 4, and 1. Now this is x to the fourth. So I'm going to add, multiply, add, multiply, add, multiply, add, multiply, add, and we get a 0. That tells us that x equals negative 1 is our first answer. Now we're down to x to the third. Well, we don't have any other answers, but there's nothing saying that answer ain't going to repeat. So let's plug in negative 1 again. And actually, when it touches at a point, then you're almost guaranteed it's going to repeat. So we'll add, multiply, add, multiply, add, multiply, and we get 0 again. Again, the fact that we get 0 one more time means that's our second answer. That's how you can tell whether it repeats, if you get 0 as a remainder. Now we're down to x squared. There's nothing saying that negative 1 isn't our third answer, so let's continue on. So add, multiply, add, and we get 0 yet again for a remainder. That means x equals negative 1 is our third answer. Now we're down to the x level, so it's probably just as easy to kick out. So we've got x plus 1 equal to 0, and we solve for x, and we get x equals negative 1. So we got 4 answers, and they're all the same. So, let's look at our last problem here, and then I'm going to go back and do at least one of the problems up above by hand, so that if you got an instructor that's wanting you to do it by hand, you can see the steps there. Or if you don't got a TI3, TI4 calculator, you can see how to do it. Now recall, this is the same example I always use over and over. x squared minus 5x plus 6 equal to 0. We would factor this. We get x minus 2 times x minus 3 equal to 0. Set each factor equal to 0. So I set x minus 2 equal to 0 and x minus 3 equal to 0. And we get x equals 2 and we get x is equal to 3. 2 and 3 are zeros. Okay. Problem number 8. They tell us n is 3. And they tell us 3 and 2i are zeros. Now instructions say find an nth degree polynomial function with real coefficient satisfying the given conditions. What they want us to do is they want us to go backwards. They're giving us the answers and they want us to go back up here and find the original polynomial. Now they're telling us n is equal to 3. What they're telling us there is we have 3 answers. And also your degree is 3. So I'm going to set x equal to 3. And I'll set x equals 2i. So that's what we did here. We set x equal to our zeros. Now there's actually a theorem that says if you're going to have an I in your answer, then you're going to have the conjugate also. So here's a positive 2i, so we're going to have a negative 2i. And that's the way it'll always work out. If you have 3 plus I, you'll have a 3 minus I. Well, take a look at what we did going from this step to this step. Looks like we took the number and put it on the same side as the x. Going in reverse. Well, that's what we'll do here. Take 3, put it over there, and we got x minus 3 equals 0. Take 2i over, we get x minus 2i equals 0. And this one, we get x plus 2i equal to 0. Well, going from this step to this step, it looks like we put parentheses around them, put them next to each other. Well, we'll put parentheses around them and put them next to each other. Now, we can't see the steps here, but if I were to go from x minus 2 to x times x minus 3 to this, we just multiply everything together. And that's what we'll do here. Now, your best choice is to multiply these two at the end first. These are conjugates. Means the first and the second part are the same. See how this is x and this is 2i? This is x and this is 2i. The sign in the middle changes. This is negative and this is positive. The neat part about conjugates is all you have to do is multiply your first parts together and your last parts. So x times x is x squared. Negative 2i times 2i gives you a negative 4i squared. Probably the only place in college algebra where you use this fact. I squared is equal to negative 1. So this becomes x minus 3 times x squared. Negative 4 times negative 1 gives us a positive 4. Now if we multiply these together, x times x squared is x to the third. Negative 3 times x squared is negative 3x squared. 4 times x is 4x. And 4 times negative 3 is negative 12. And that would be our answer. Okay, now I'm going back. Maybe the first problem here. I'm going to do this one by hand. Now the current textbook we're using, let me clear this out. Current textbook we're using, time for that to blow up. Third time's a charm. Current textbook we're using actually has a lot of instructions on how to do it by hand. So if you read the instructions like, well, this doesn't make any sense, it doesn't look like what he's showing, that's because they're guiding you to do it by hand. Okay, so we're wanting to find the zero, so we set it equal to 0. Now doing this by hand, this is going to be our p, the number at the end. The number at the very beginning is our q, and it's the invisible 1. Now we're going to write down all products give us 40. Well, 1 times 40 gives us 40. And negative 1 times negative 40 gives you a positive 40. So to handle all the signs, we're going to do plus or minus 1. And I don't know how many we're going to have here. 2 times 20. So we'll have plus or minus 2 and plus or minus 20. We have 4 times 10, so we got plus or minus 4 and plus or minus 10. And we got 5 and 8. So we got plus or minus 5 and plus or minus 8. So those are all the products that give us 40. Now for the q, since it's the invisible 1, the only thing that gives us that is either 1 times 1 or negative 1 times negative 1. Now all of our possible answers are P over Q. So I take each value of P and put it over the Q. So we got plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 5 over 1, plus or minus 8 over 1, plus or minus 10 over 1, plus or minus 20 over 1, and plus or minus 40 over 1. Which gives us plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, and plus or minus 40. Okay, so those are all of our possible answers. Now I say answers, I'm talking about ones that can be written in rational form. Like this, fraction form. Well, what we do is we start with our first one, like negative 1. It's our first answer here, and we plug it into synthetic division, see if it's one of our answers. Well, what do I mean it's one of our answers? Well, if we go through synthetic division, our remainder is 0, that means that's one of our answers. So add, multiply, add, multiply, add, multiply, add. We don't have 0 as remainder, so that's not one of our answers. So we'll go to the next one, 1. And I'll plug it in synthetic division. So add, multiply, add, multiply, add, multiply, add. Looking for a 0 as remainder, so that's not one of our answers. So we'll go to the next one, negative 2. Usually the one I'd screw up on when I took college algebra way back in the dark ages when there was no graphing calculator, is the one I'd screw up on was actually the one that was the answer. So I'd go through all of them, trying all these possibilities, 1, 2, 3, 4, 5, 6, 7, 8. I'd do 16 synthetic divisions, and then turn around and have to redo them because I missed one of them. So let's see, add. Anyway, I'll quit whining about the old days. Okay, add, multiply, add, multiply, add. Still not there. Okay, so let's plug in the next one, which is positive 2. You get very good at synthetic division. Of course, now that I'm saying that, I probably got like 2 or 3 errors on there, but okay, add, multiply, add, multiply, add, multiply. Ooh, this looks good. We got 0 as remainder, didn't we? That means that x equals 2 is our first answer. Now, keep in mind this started as x to the third, so now we're down to x squared. This is x, and this is no x, or constant term. Once we get down to the x squared, we can kick out and then either factor it or use a quadratic formula. Well, this factors using the PSD method. So this is factors as x minus 5 times x plus 4 equal to 0. Set each factor equal to 0. So I got x minus 5 equal to 0 and x plus 4 is equal to 0. And you get 5 and you get negative 4. Now if you're doing these by hand, though those are our 3 answers by the way, our largest power is x to the third, which means we have 3 answers, and we found 3. Now if you're doing these by hand, be sure to watch the first examples where I do it on the calculator, because the point where you find your answer and start breaking it down into the quadratic formula and different techniques like that, that's the same if you're doing it by hand. Here we're trying all the possibilities to see which ones are answers. If you're using technology, you're using the calculator to tell you what those answers are. And that's the end of that section. So let me go ahead and stop the recorder.